Hi, my name is Cassandra Champagne. I'm a PhD student at the University of Michigan, and today we are going to be doing the hydrometer test. Before we get started, always remember to have your safety glasses on when you're in the lab. So if you would like to follow along with your with your lab manual, I'm first going to go over the equipment that is required for this test. The first piece of equipment is our sedimentation cylinders. We're going to be using 3 for this lab, seen here. We also need a graduated cylinder, shown here. Also a hydrometer, which is this device here. We also need a rubber stopper, which looks like this, which will be used with the sedimentation cylinders. We also have our solution of 4% Calgon solution, and Calgon is our hexametaphosphate chemical. It's our NaPO3 and it's used as our dispersing agent in this lab. I also have a bowl here containing our soil specimen. I have already pre-weighed 50 grams of the material that reached the pan from the sieve test. So this is the material that would have passed the number 200 sieve. And then we also have our mixer. So this looks like our little milkshake machine here. We have the mixing cup as well that will basically go in here like this. And lastly, we have some deionized water. We'll have this in a squirt bottle as well as a larger reservoir of the DI water here. And that wraps up our materials. So let's get started. So the first thing that we're going to do is determine the meniscus height. So we're going to be using the sedimentation cylinder that's marked H2O, and we're going to need to fill it up with deionized water up to the 1,000 milliliter line. So first, we're going to fill it almost all the way up to the line with the water from the jug. And then once this gets close to the 1,000 milliliter line, we're going to stop the water flow and fill it the rest of the way up with the squirt bottle of deionized water so we can be precise. And just make sure you get level so you can see. And perfect. Okay. So now we're going to take our hydrometer. You want to be very careful in handling the hydrometer. I'm going to carefully put it into the sedimentation cylinder and release it. So once it stops bobbing, one thing that you want to make sure is that it's not, basically you can see right now, it's not next to one side of the cylinder. You want it to be centered in the cylinder as much as possible. And then the reading that we're going to take is the height of the meniscus, so the difference between the bottom of the meniscus and the top. And then we're going to record that on our data sheet. Okay. So next we need to determine the zero correction factor. So for that we're going to be using the second sedimentation cylinder labeled NaPO3. So first we're going to need 125 milliliters of our 4% Calgon solution. So we're going to use our graduated cylinder. This one happens to go up to 100, so I'm going to fill it up to 100, dump it in, and then fill it up again to 25 to get 125 milliliters. Okay. So there's our first 100. Pour that in. And then 25 milliliters more. Okay. And then pour that in. And then just like the previous cylinder, we're going to fill this one as well, all the way up to the 1,000 milliliter mark. So again, I'm going to fill it most of the way from the jug just because that's faster. And then we're going to finish it off from the deionized squirt bottle. Again, just to make sure that we're getting a precise water level. Okay, and there we go. So now we're going to take the hydrometer from the first sedimentation cylinder and put it in the second. Again, be very careful with the hydrometer. Okay, make sure it's centered in the cylinder as much as possible. And then we're going to be taking the reading from the 0 mark on the hydrometer to the bottom of the meniscus and recording that on our data sheet. And these readings are in units of divisions, as your data sheet should reflect. So now we're going to take the hydrometer out of this solution, and we're going to put it back into the deionized water. We no longer need the second sedimentation cylinder for the rest of the lab, so I'm going to move that aside, and then we'll get started with our soil mixture. Okay, so now we're over at our mixing station. So the next step is going to be to take our mixing cup and add 125 milliliters of our dispersing agent here and the 50 grams of soil that we pre-weighed. So first I'm going to use my graduated cylinder again to measure out 125 milliliters of the hexametaphosphate solution. All right, so there's 125 milliliters of our dispersing agent. And then here's our 50 grams of our fine soil that passed the number 200 sieve. We want to make sure that all of it gets in there, so be very careful not to lose any soil. And once it looks like you've gotten all of it, I'm just going to use a brush to get any of those finer particles in there. Okay. Then once you're satisfied with that, you can switch it around a little bit, but we're going to put it onto the mixing machine and use a stopwatch to time the mixing process for 1 minute. So now that we've finished mixing our soil and dispersing agent, we need to transfer all of the material from the mixing cup into the sedimentation cylinder labeled soil. So I brought the mixer over here because we need to make sure that all of the material makes its way into the cylinder, and this includes any material that may still be on the probe that's used to mix. So what we're going to do is place the mixing cup beneath the probe and use the deionized water to rinse off the probe like this, just to make sure that all of the material makes its way into the cup. Okay. Once you're done with that, we can pour the mixture into the sedimentation cylinder. You can see it's a really milky mixture. Okay. So now there's still deposits of the mixture in this cup. This cup needs to be rinsed out with deionized water, but there's also 4 sets of vertical rods inside the cup that just add additional surface area for material to get deposited onto. So we need to make sure we do a really good job at rinsing this cup out and making sure, again, all of the material makes its way into the sedimentation cylinder. So I'm just going to start by rinsing and pouring into the cylinder. You can kind of rinse and turn, a little bit of technique to this until you've gotten everything into the cylinder. It's very important that you're thorough on this process. And once you're satisfied that you've gotten everything, make sure you pay attention to the bottom of the cylinder as well as the sides, the bottom of the cup as well as the sides. But once you're satisfied that you've rinsed everything out and all of the mixture has made its way into the sedimentation cylinder, we're going to want to fill the cylinder again up to the 1,000 milliliter line with deionized water. So there we go, filled up to the 1,000 milliliter line. Okay, so now we need to mix the mixture. So we are going to put the rubber stopper on the top. You don't have to push it in very hard, but you are going to want to keep your hand over the rubber stopper to keep it in place. I'm going to take the stopwatch in my hand and start mixing this mixture. Now, in order to mix, we really just need to turn it over repeatedly. And we're going to do this until we no longer see soil getting stuck to the bottom or the sides of the cylinder as we're mixing it. So this could take a little bit of time. And while I'm doing this, I'm going to explain what's going to happen next because it's going to happen very quickly. So this is why I have the stopwatch in my hand already. As soon as I put this cylinder back on the table, the settling of the particles is going to start immediately. So I need to start the stopwatch basically as soon as I put this cylinder back on the table. And then I only have 15 seconds to take the first reading, which consists of putting the hydrometer, which is currently in the deionized water cylinder, into this cylinder, letting the hydrometer stabilize enough to take that reading. So that all happens very quickly. After the 15-second reading, I'm going to take another reading at 30 seconds, 60 seconds, and 2 minutes. You can take a look at your data sheet to see the sequence of measurements that would typically be taken after that, all the way up to 24 hours. But we're not going to show all of that here. Another important thing to note that we're not going to show here is that after the 2-minute reading, we would typically stop the stopwatch, take out the hydrometer, replace the rubber stopper, and mix it like this all over again, and basically start the readings back from the 15-second reading. And what we're doing is repeating those first 4 readings and comparing the results that we get to make sure that they're the same and that we're getting good repeatability. And then at that point, assuming that they were the same, you would then continue on to the 4-minute reading, 8-minute reading, etc., all the way to 24 hours. Okay, so now that we've been mixing this for quite a while now, I am satisfied that the mixture is homogeneous. So I'm going to mix it just a couple more times and then set it down on the counter and immediately start the stopwatch and start taking our readings. All right, so we're going to start now. Grab the hydrometer, carefully but quickly set it in. And our next reading is right now. So we're going to record that onto our data sheet. Now, we're taking the reading at the top of the meniscus because we can't actually see the bottom in a cloudy mixture like this. Our next reading is already coming up right now. Go ahead and record that on your data sheet. And that was our 30-second reading. Next reading will be at 1 minute, but we also need to take the temperature. However, we don't want to introduce anything else into this sedimentation cylinder, so we're actually going to take the temperature in this cylinder because everything is at room temperature, so the temperature will be the same in both. And then you can record that temperature on your data sheet. And now it is time for the 1 minute reading right now. You can go ahead and record that on your data sheet. We can let this now sit in this sedimentation cylinder. The next reading will be at 2 minutes. And what happens after the 2-minute reading is we would take the hydrometer out of the sedimentation cylinder because at that point the readings get spaced out a little bit further, and that allows time for the particles to actually settle on the hydrometer bulb itself, and we don't want that. So between all of the subsequent readings past 2 minutes, we would take the hydrometer out and let it sit in this cylinder and only put it back in right before we need to take the next reading. So we have about 20 seconds before the 2-minute reading, and that's the last reading that we're going to show just for the sake of this video. Again, we would usually repeat these first 4 readings, but again, just for the sake of this video, we're not going to show that here. We have 5 seconds for the next reading right now. Okay, so now that we've passed the 2-minute reading, we're going to take the hydrometer out of the suspension and we can stick it in our water. You can do a little bit of swirling of the mixture, or swirling of the hydrometer in the water just to get the soil off of it. And so, like I said, we're not going to continue to show you all of the readings for the next 24 hours. However, we are going to provide you with some images so you can actually see the soil settling in the sedimentation cylinder. It's actually already starting here at the bottom, and as time goes on, you'll be able to see it more and more pronounced. And that's the end of our hydrometer test video.